video, what we saw was the program for the recursion of a factorial of a number. Now let's study that program in detail. What we did was, this was the function which was used for factorial, int num. It was returning a long int. So this was the function, and what we wrote was, if num is greater than equal to 1, it should return num multiply by factorial of, or means name of the function, num minus 1, else return 1. So this was the main logic. Let us return this logic. We passed 5, so num, the value of num is 5 at the moment. If num is greater than 1, so 5 is greater than equal to 1. This is true. It comes over here. What is this return doing? Num becomes 5 multiply by factorial of 4. So this function is again called. This function is again called, and this time the value 4 is passed. So now the new value of num becomes 4. It again comes over here. It checks 4 is greater than equal to 1, and it goes again in the return statement. And what happens this time? 5 multiplied by factorial of 4 multiplied by factorial of, what is this, num minus 1 this time? Factorial of 3. So these calculation keep on going on. 5 multiplied by factorial 4 multiplied by factorial 3 multiplied by factorial 2, and greater than 2 is greater than 1, it comes 1 is equals to 1, it comes again, and 1 minus 1 factorial of 1, and then finally multiply by factorial of 0. So this return statement is doing this thing. Now this is evaluated as a stack, last in first out. Stack is a data structure known as last in first out. What happens? This statement is being computed in such a way, the last statement is factorial of 0. So factorial of 0 is calculated from this thing, else return 1. 1 is returned over here. We get 1 from this. Then this factorial of 1 is computed, then factorial of 2 is computed, then factorial of 3 is computed, then factorial of 4 is computed, and finally by getting all these value, it return the final answer, that is 120. So this is how the factorial computation or the recursion computation is done.